His current research program is devoted to nanoscale imaging and spectroscopy and modeling and simulations, both with focus on applications in biology and medicine, as well as to the design of nanoscale optoelectronics materials and devices. He is an NSF Career Awardee and director of an NSF REU site. He has published over 70 papers to date with H-index 32 and I-10 index 51. Okay, Professor, can you start, please?
Okay, so first of all, I want to thank CALAF and the College of Sciences and Department of Chemistry to invite me to give this talk. And what I'll talk about here is the work that CALAF did in my research group during his PhD work. Okay, so here we'll talk about using polymer nanoparticles to deliver iron for nanotherapy towards tumor cells. And so we're located at the University of Central Florida, which is in Orlando. And let me get up a pointer. Here you go. So we are here in Florida in the United States, close to Kennedy Space Center. And this is our Department of Chemistry building on main campus. And this is our group when CALAF was part of our research. Right, and so our acknowledgements for this work are the Mosher Scholarship that CALAF received for his PhD work. I also want to thank the Iraqi Journal of Science for sponsoring this event, and then also Doctors Abood and Hamid for basically allowing this to proceed and helping out with setting up this conference at the Tكريت University. So thank you.
Okay, let's see the audience. If there's any question, please raise your hand.
What about using platinum instead of iron? Platinum.
Okay, Professor, can you hear me?
Yes, I can hear you.
Yeah, there's a question. Can we use the platinum instead of the iron?
This process, in a large part, depends on the oxidation state of the metal and the oxidative properties. So, the redox properties of platinum would have to be compatible with this process to react with hydrogen peroxide to create reactive oxygen species. So that would have to be looked at to make sure that this is possible. The other issue is that iron is already part of our body. So if we use this as a treatment, in a way, this is a, let's say, non-toxic, biocompatible way of doing the ferroptosis process. When we use platinum, this is basically a metal that is not really abundant in the body. So there would be more concerns about, using this as a drug compared to iron, which is, again, our body can process, whereas platinum would probably accumulate in the body.
Professor, can I go to slide number 2? Yes, this slide. Okay.
Yes, in sunlight, if you use a specific lambda max, for example, 420, 470, is good, or we can use just general for use sunlight or visible light?
Okay, so if we're talking about photodynamic therapy, which we originally tried to do, we would have to match the lambda max of the polymer for the PDT to work. So for this polymer, the lambda max is in the 600-700 nanometer range. Right, so when people do photodynamic therapy, the wavelength has to match the absorption of the material they're using to create reactive oxygen species. Same thing for photofrin, they have to use the right wavelength. The issue is that unless the wavelength is in the near infrared, the light is not really going to be able to enter the skin all that much, because the skin will actually absorb most of the light.
which type of polymer is compatible with the body, or another type of polymer?
Okay, Professor, is this polymer, can you go please to the slide number 3, I guess? 4. Scheme, the scheme.
Let's see. So, which slide, Khalaf?
Yes, this one.
Okay.
Okay.
About the polymer, is compatible with the body?
Okay, the starting materials, the PCP, DTBT, and the PSPO, CUH, is it compatible to the body?
Okay, so we did control studies for that, and we found that that the polymer itself, the cell culture is not affected by the polymer. So we know the PSPEO carboxylate, that's similar to polyethylene glycol, which is FDA approved for use in the body. So that polymer is definitely compatible with the body. The PCP polymer, that polymer we looked at in cell culture, and we did not see significant toxic effects until we made nanoparticles. So, but in terms of, putting this as a nanotherapeutic medicine, we would have to go through the FDA process to get approval to put it in the body. But for now, the data suggests that this would be compatible, and we would expect this to be excreted from the body after treatment.
Thank you.
Okay, thank you, Professor, for joining us, and hopefully we can continue on this in the future.
Yeah, thank you again, everyone, for attending and inviting me to this conference. I really appreciate it.
You are very welcome. Thank you so much.
Thank you.